Hi linear algebra students. In this video, I will explain a formula that I pretty much just threw at you in class, okay, without really justifying it. It's the formula of the projection of V on U, okay? So in this video, which is optional, you don't have to watch it, you don't have to fill in the notes. I'm going to show you how can we actually construct that formula. So what is our goal by that allows us to write this formula? So the goal, and this is what I said in class, is to decompose a vector, so a vector v, into a component that's parallel to u and a component that's orthogonal to u, okay? Let's actually write this down. So our goal is to decompose a vector v, okay, so it's the v that's in my picture, okay, into a component, so into a component parallel to a given vector u, to a given vector u. So in this case, the vector u is the green one, and that one is given to us, right? We know what it is, okay? And a component that is perpendicular. So, and a component perpendicular to you, or orthogonal. Let's write orthogonal. To the same vector u. Okay, well, remember that the component parallel, we want to call it the projection. So projection of v on u. So like this is what we want. And the component that's orthogonal to u, we call it the perpendicular component. So the perp of v on u. Okay, so we want to find these two vectors. So that's the problem that is given to us, right? We just have two vectors u and v, and we want to find out what these two vectors could be. And this is pretty much a cooking recipe in the sense that we will use the angle theta that's right here. And what do we want? Okay, so we want from the picture that you can see here, we want to have that the projection of u, so projection of u of v on u. So if we calculate the norm, what measurement should we have? Okay, we should have the norm of v times the cosine of the angle theta. Okay, so let's actually write this down. We would like the norm of the projection to be the norm of v multiplied by the cosine of the angle between u and v. Okay, so you can see that this angle is right here. And then let's write what we know, okay? And actually, first of all, let's stop here for a while, okay? So we want that, and something else that we want. I'm going to write it right underneath. So we want the direction of this vector to be the same as the direction of u. So perfect. Actually, let's write this. We want projection of v on u to be in the direction of u. So to be in the direction of u. Okay. And the principle is really simple. As you guys know, a vector can be thought of an arrow of a specific length and a given direction. Okay, so that's the way we engineer that vector. So okay, so the projection of V on U, okay, um, so in other words, what we will do is we will engineer its length. Okay, so it will be the length of the projection of V on U multiplied by the, how can we make it have the direction of U? We can multiply it by U hat, which you should remember is a unit vector, okay, in the direction of U. Let's write that down. Unit vector, okay, in direction of U. And this, by the way, is a definition, right? It's not a theorem or anything like that. It's just the way we want the projection of the vector to be. We want it to have a given length, which will be given by this, and the direction, which will be given by the direction of U. Now, let's replace everything in, okay? So, we have the norm of V multiplied by the cosine of theta. Now, the cosine of theta, we also have a formula for it. Okay, so we saw earlier that the angle between two vectors is u dot v over the norm of u times the norm of v. Okay, so this is actually our cosine of theta. All right, just so that you can see very well. Last thing. Okay, now, okay, it's easy from the vector u to construct the vector u hat, and the way we do it is really simple. We take the vector u and we divide by its norm, okay? But as you can see, since things will factor out or like cancel properly, it's nice to actually write this out in our formula instead of just writing u hat and having to compute it every time. So we enter that, and what do we get in the end? Well, very simple. This cancels with this. So you see there's two norms of V that cancel. And we get that the formula, so let's write it in purple now, is going to be the formula that I threw at you in class, right? The norm of U dot, the dot product of U and V divided by the norm of U squared, right? So norm of U squared multiplied by U. So this is the formula for the projection. Okay, so this is the one that's important to know, to like, I would say remember, but also it's nice if you can engineer it. That makes you remember it much better. And the formula for the perpendicular of V on U, once you have the projection, it's really simple to engineer the orthogonal component, because V is straight up the addition of the projection and the perpendicular, and that's exactly what we want. So, well, basically, let's just write this. Let's just write what we have said. So V is equal to the projection plus the perp. And there's no magic formula for the perp, by the way. So the way you calculate the perpendicular component is really just by subtracting the projection from V. So perp V on U is simply equal V minus the projection. So there you go. There you go. You have this formula. So hopefully this is helpful. So to understand the entire setup, I think it's a good thing to have. So see you either in class or in the next video.